All right, today we are going to continue on with section 8.1. Um, Before we've talked about factorials, which is when you've got that exclamation point, so like for example, if I had 3 factorial, that would be all the things from 1 to 3 all multiplied together. Or if I had 7 factorial, that would be all of the numbers leading up to 7 multiplied together. Okay, now those were easier to handle. Here's an example that might look a little strange. We have factorials, but we have n. And so that's a little bit more generalized. So for example, on the bottom in the denominator, we have n factorial. So that would be all the things leading up to n multiplied together. So I don't know what n is. All I know is that it's, starting at 1, a whole bunch of things multiplied together all the way up until n. That's just very generalized looking. Now on the top, I have n plus 2 factorial. So that means we're going 2 more beyond what n is. So again, I would start with like 1, 2, 3, and then it would keep multiplying up until n. But then n plus 2 would be 2 terms after n. Okay, so think about this carefully. What would be the term after n? The term after n would be n plus 1. The term after that would be n plus 2. Okay, so it's all the things being multiplied together. I don't know what n is. I don't know where the stopping point is. Let's just pretend for a second that n was 10. Do you see how n plus 2 would be 2 more than that? So it'd put you at 12. N plus 1 would be 1 more than n. That would be 11. So me writing n plus 2 and n plus 1 and n is just indicating, all right, this is how much farther beyond n the top is going. Now, the thing that we can do is we can cancel out the stuff on top and the bottom that are the same. And we're multiplying, so we can do that. So I have 1 through n on the bottom that would cancel with 1 through n, excuse me, on the top. So what do I have left? I have n plus 1 times n plus 2 left on the top. So that would be my answer. It's very generalized looking. Okay, now sometimes that's a little bit harder for people to process. So if that's the case, that's totally cool. Oftentimes in math and in science, when we try to generalize, it's sometimes easier if you start small and then look for patterns. So like, let's say that n equals 3. We'll just pretend, okay? So if I have n plus 2 factorial over n factorial, and we're pretending that n is 3, that would be 3 plus 2 factorial on the top, so that'd be 5 factorial, and then on the bottom would be 3 factorial. And I know that 5 factorial is 1, 2, 3, 4, 5 all multiplied together, and I know 3 factorial is 1, 2, 3 all multiplied together. And then do you see how we can cancel the 1, 2, 3 and the 1, 2, 3 from top and bottom? And I'm left with 4 times 5. Now I know that's 20, but just let it sit there for a second and let's keep looking for patterns. So like, let's pick another value of n. Let's say n equals 7, how about? Okay, so then n plus 2 factorial on the top, 7 plus 2 would be 9 factorial, and then the bottom, n factorial, would be 7 factorial. And then, so this would be 1 through 9 all multiplied together. And then on the bottom, 7 factorial would be 1 through 7 all multiplied together. And you'll notice that the 1 through 7 and the 1 through 7 on top and bottom will cancel. So I'll just be left with 8 times 9 on the top. Now I could keep going. If I'm not seeing a pattern, I could certainly keep going. But here's what I want you to notice. Look at the value of n, and then look at these two numbers that we have left over that are being multiplied together. So here's another example of n and these two numbers being multiplied together. Do you see how this first number is 1 more than n plus 1? And the second number is 2 more than n plus 2. Same thing happens here. N was 7. This first number is 1 more than 7. And the second number is 2 more than 7. So it's looking like no matter what I do, no matter what number I plug in for n, my result is going to be n plus 1 times n plus 2. And I can come to that conclusion using actual numbers and looking for patterns, or I can do the more generalized approach like this. And I guess I would say whichever way makes more sense to you, go for it. But sometimes it's easier to start small, starting with something that you know that makes sense, and then trying another small thing that makes sense and looking for patterns. Okay, so it's just an idea. If you take calculus, you're going to see this kind of idea coming up. So I just wanted you to have some exposure to that this year. Okay, now the next thing I want to go over is how to do summation problems a little quicker. There's some rules that we can use that are going to be to our advantage. Okay, so here's our first example. If I have the sum from 1 to 5 of 2k, the long way would be for me to plug in a 1, so it'd be 2 times 1, plus, that's what summation means, is we're going to be adding things up, plug in the next thing, which is a 2, so 2 times 2, plug in the next thing, which is a 3, plug in the next thing, which is a 4, plug in the next thing, which is a 5. All right, I can certainly do this. There's only 5 terms. It's not that bad. So I would have 2 plus 4 plus 6 plus 8 plus 10. And when I add all of those up, I'm going to get 30. Okay, totally fine to do it that way. Or I can use this property. Now, it's written in a very generalized form, but the idea is we have c, which is some constant, times a variable. And this has a sub I with this idea that we would be plugging in, maybe these should be i's actually. I would be plugging in some value of I in here, so I'd be plugging in a 1, then a 2, then a 3, etc. Just like here, I'd be plugging in a 1 for k, then a 2, then a 3, etc. But the idea is if I have a constant being multiplied by that variable, I can pull the constant out in front. So just like this problem, I'm going to rewrite it. Okay, I've got a constant times a variable. This property is saying I can take that constant of 2 and I can put it out in front of the summation. All right, now what this does is I've got a 2 out in front, and then I'm going to do my summation. And I'll put the summation stuff inside parentheses. And once I'm done with all of that stuff, the summation stuff, I'll just multiply by 2. So here, all I have to plug anything into is just a k. And I'm going to start by plugging in a 1 in for k, then a 2 in for k, then a 3, then a 4, then all the way up to a 5. So with my constant of 2 out in front, I can just add the 1, 2, 3, 4, 5 up. And when I add those up, I'm going to get 15. And then multiply by 2, I'll get 30, which is the same answer that we got up here. So using this property basically just pulls out all of these common 2's. It's like it factors out the 2's, and then it leaves you with easier stuff to add up. So that's just an option that you can use to help make things go faster for yourself. Okay, here's another property. This looks weird because there's no k. So there's actually nothing for us to plug in necessarily. What that means is that our term is going to be a 5 always. And going from 1 to 4 means I'm just going to have 4 terms. It just so happens that each of those 4 terms is a 5. The first term's a 5, the second term's a 5, the third term's a 5, the fourth term is a 5. Always going to be a 5. This is just telling us how many terms we're going to add up. So here we're adding up 4 terms, all happen to be 5s. My answer is a 20. Okay, what this property down here in very generalized form is saying, if this is just a constant, multiply the constant by the number of terms you have. So this is a constant times the number of terms. Okay, so that's going to work with this example as well. I'll rewrite it. I know that there are 4 terms from 1 to 4. And I know that this is always going to be a 5. It's just a constant, 5. So if I take my constant of 5 and I multiply it by how many terms I have, I get the same answer as I did up here. Now, if this was going from like 1 to 100, I would definitely want to do it this way. It's so much faster. Okay. All right, here's another example. The long way of doing this problem would not be very fun. So the long way would be to plug in a 1. So I would have 24 minus 3 times 1 plus, and then I would plug in my next term, which is a 2. So 24 minus 3 times 2 plus, then I would have to plug in a 3. 24 minus 3 times 3 plus 24 minus 3 times 4 plus 24 minus 3 times 5 plus, and I'm going up to 6. So here's my last term, 24 minus 3 times 6. Okay, that's not terrible. It's only 6 terms, but if this was like 100 terms, I definitely would not want to do it this way. So here's the property that I can use. And again, it looks complicated because it's very generalized, but what you're going to notice is you've got multiple things inside the parentheses being added or subtracted. And then you'll notice that the sigma is broken up into 2 individual things being added or subtracted. So when you have multiple terms, I'm going to rewrite this. Okay, from n equals 1 to 6, 24 minus 3n. Okay, what this is saying is I can split the 24 and the 3n up into their own summations. Still going to go from 1 to 6, but I would have just a 24 and then minus, because it can either be adding or subtracting. And then again, another summation from 1 to 6 of 3n. Okay, now I can apply the previous 2 formulas we talked about. This is just a constant, 24. And so it's going to be 24 plus 24 plus 24 plus 24 6 times because there's 6 terms. Over here I've got a variable times a constant. And the first rule we talked about was the fact that this constant can get pulled out in front. So really, I guess I could rewrite this from 1 to 6 of 24 minus, and then put the 3 out in front of the summation. Okay, so now, I'm running out of some space here, but this is going to be a 24. It's going to be a constant 24 6 times, because there's 6 terms, minus 3 times, and now we're going to add up from 1 to 6 of n. So you're going to plug a 1 in for n, then a 2 in for n, then a 3 in for n, then a 4, then a 5, then a 6. Okay, so now I can do 24 times 6 minus 3 times all of this stuff added up. And when we do that, we should get 81. And I forgot to do that up here, but if you had done it this long way and typed it in your calculator, you would also get 81. So it's kind of like your choice. Which method do you want to use? I think eventually this method down here of splitting it up is going to be the faster method. And if you take calculus, splitting up like this is going to make your derivatives and integrals a lot easier to handle. So it's worth learning. Okay, now I just wanted to tie this kind of back to what we've already learned, because if you can identify that something is arithmetic or geometric, it's going to be so much easier to do your summations, because remember, we have formulas, okay? Now this is the summation formula if it's arithmetic. So you would have to establish that before you go ahead and use this formula. How do you do that? Well, I would say plug in some of the first numbers just to kind of get a sense of the pattern. So for example, if I plug a 1 in, my first term would be 5 times 1 minus 3. So my first term would be a 2. Actually, I'm going to use a plus sign because we would be adding because of the summation. Okay, so that's what I get when I plug a 1 in. Now if I plug a 2 in, 5 times 2 minus 3, I would get a 7. If I plug a 3 in, I'd have 15 minus 3, and I would get a 12, etc. Now, do you see a pattern between these numbers? It looks to me like we're adding 5 each time, right? So if we're adding 5 each time, that means it's arithmetic. So if I take the time to do that and figure out that it's arithmetic, I could use this summation formula. Actually, I just made a mistake, and I can't pause the video and fix it, so I'm going to have to explain what my mistake was. And actually, I'm kind of glad I made this mistake because a lot of people make this mistake. I was just treating the problem as if the summation applied to both the 5n and the minus 3. Remember when I plugged in a 1, I had 5 minus 3, and that's how I got a 2? That was wrong. There's no parentheses around it. So the summation only applies to the 5n, and then the minus 3 should be kind of left toward the end. So if I'm looking at my first few terms, if I plug a 1 in here, my first term in the summation would be a 5. And then if I plug a 2 in, my second term would be a 10. And if I plug a 3 in, my third term would be a 15. So yes, I'm still adding 5 each time, and it's still arithmetic. So that's good. But the summation, this sum formula, will only apply to this stuff. And then at the end of that, we'll subtract a 3. Okay, so let me try to color code here. All of this summation stuff is arithmetic. So I can use this formula. N, remember, is the number of terms. There's 36 terms from 1 to 36. So I could do 36 divided by 2. My starting term is what I get when I plug a 1 in. So 5 times 1 is 5. Plus, my ending term is what I get when I plug in a 36. So if I do 5 times 36, I will get 180. Okay, so that is all of that summation stuff. And then at the very end, I would subtract a 3. Let me write up here just as a reminder that this is your starting term and this is your ending term, and n is the number of terms. Okay, so now when I plug this in my calculator, let's see, I should get, for my final answer, 3,327. Okay, now I want to point out that that's not the only way to do the problem. I could do the problem slightly differently. Going back to the original way it was written. See, the thing is with these, there's always more than one way to do the problem. So I kind of want to show you a bunch of different ways so that you can pick the way that you like best. Okay, let me separate this a little bit more. Okay, so using the rules that we learned in the last couple slides, and again, remembering that the summation is only applying to the 5n, not this minus 3, because there was no parentheses. I can, though, take this constant out in front. That was one of my new properties. So I could put the 5 out in front. Okay, so that means that now I'm just summing up n. So I still have 36 terms. So 36 divided by 2. My first term is what I would get when I would plug in a 1. Or my starting term is what I get when I plug in a 1. My ending term is what I get when I plug in a 36. And it's just an n. So plugging in a 36 would be 36. And then after I do all of that and I multiply by 5, then I'm going to subtract the 3. And if you type that into your calculator, you also get 3,327. Okay. Or the long way would just be to plug in a 1, then plug in a 2, then plug in a 3, all the way up to 36. Do all of that, and when you get done with that, subtract the 3. It's just kind of a matter of what you think is fastest or easiest. Let's try another one. Okay, when I see this problem, I'm noticing that I've got something times something to a power. And when you see that, something times something to a power, that's geometric. And here's our summation formula for geometric. There's your starting term. And then n is your number of terms. And r, both there and there, that is your common ratio. That's the thing being raised to the power. Okay, so in this problem, if I'm recognizing it's geometric, I'm just going to use this formula. My starting term is what I get when I plug in this 1 right here. So if I plug in a 1, this exponent would be 0. 1/4 to the 0 is 1. 1 times 32 is 32. So that's my starting term. R is the thing being raised to the power, which is 1/4. N is the number of terms. There's 6 terms from 1 to 6. Okay, and I type that in my calculator, and my answer will be, I can write it as a fraction, 1,365 over 32, or I could write it as a decimal, which would be 42.6563. Okay. Otherwise, the long way to do the problem would be to just plug in the numbers 1 through 6. So it would be 32 times 1/4 to the 1 minus 1 plus 32 times 1/4 to the 2 minus 1 plus 32 times 1/4 to the 3 minus 1, and so on until you have 32 times 1/4 to the 6 minus 1. Now you certainly could do it that way. It's just, it's up to you which method is going to go quicker for you. If we were taking a test in a normal school setting and you only had 40 minutes to take your test, you would want to do it the fastest way possible. Okay, so here's just another one, just to see how you're doing. There's no variable, This is just a constant. It's always going to be a 5. How many terms are there? There's 12 terms. So I can just do 5 times 12 and get my answer really quickly. So I get 60. Okay, that was one of the properties from today. Again, this is to my point earlier when there's parentheses versus no parentheses. So in this problem, I would be doing the 4k minus 2. All of that, like plugging in a 1 into 4k minus 2, then plugging in a 2 into 4k minus 2, all the way up to 28. But over here, there's no parentheses, so the only thing that's being summed up is the 4k, and then when you're done with that, then you subtract the 2. So if it was me doing this problem, what I would do is I would take that 4 and I would bring it out in front. And I would just take the sum of k from 1 to 28. And when I get done with that, then subtract the 2. Now, I know this is arithmetic because if I plug in a 1, then a 2, then a 3, then a 4, then a 5, they're going up by 1 each time. You're adding 1 each time, which is arithmetic. So I know then I could use my formula for arithmetic going back to here. I can use this formula for arithmetic. So I take my number of terms, which is 28, divided by 2, and then my starting term would be a 1, because I'd start by plugging a 1 in for k, and then add, and my ending term would be plugging in this top number, 28. Okay, so I have this 4 out in front, because I can put the constant out in front. Here's my summation from 1 to 28 of k, and when I'm done with that, then I'm going to subtract a 2. So if I type all of this stuff right here in my calculator, I get 1,624, and then I'm going to subtract that 2. So my final answer is 1,622. Now, that would be different than if I had parentheses. So if I have parentheses, I would be allowed to break up this summation into 2 separate summations. So I could do the sum from 1 to 28 of 4k minus the sum from 1 to 28 of 2. And again, I've got a constant, so I could put that constant out in front and just do the summation of k. Okay, so I've got the 4 out in front. I'm summing up k, which again is arithmetic. So I'm going to use my arithmetic formula. Number of terms divided by 2. First term would be a 1, plus last term would be a 28. Okay, so that's my summation times 4 minus, and then this is a constant 2, multiplied 28 times because there's 28 terms. So all of this stuff would be 1,624, but now I would be subtracting 2 times 28, which is 56. And when I subtract those two from my final answer, it's 1,568. So the parentheses matter, okay? So be on the lookout for whether there's parentheses and everything is being summed up, or no parentheses, and then it's just the stuff directly next to the summation symbol, and then anything being added or subtracted at the end would come last. So just be careful of that, okay? All right, and then here are some last formulas for you guys. You're going to see these in calculus, so I would write these down. Just pause the video and write these down. These are going to make your life a lot easier when it comes to things being squared or cubed or to the 4th or to the 5th power. The thing to just know is that n is the number of terms. So that's basically all you need to know. Like if you have a problem like this, you would just need to know how many terms you have. And then that would go in for n here, here, and here. So let's try, let's try this one. Okay, So this looks intense, but what I would do is I would break it up. Because I have parentheses, I'm going to split up the summation symbol for the k squared and then for the 6k. And then the other thing I'm going to do is, because this is a constant 6, I'm going to bring that out in front. So I'm going to copy down this first one, the k squared term, but here I'm going to bring this 6 out in front. Okay, now I'm going to use my formula, and I'm going to kind of color code it. So this part right here, I can use this k squared formula. Well, here it was an I squared, but it doesn't matter what the letter is. K squared works too. So here's the formula I'm going to use. And n is the number of terms. So the number of terms from 1 to 100 is 100. So I'm going to do n, which is 100, times n plus 1, so 100 plus 1, times 2n plus 1, 2 times 100 plus 1, all over 6. Okay, and then I have a minus 6, and then I'm going to do this summation right here in blue. Okay, and this is just k, which is arithmetic. So I would do the number of terms, which is 100, divided by 2. The first term is what I get by plugging in this bottom number, 1. And the last term is what I get by plugging in the top number, 100. All right, so then I would type all that in my calculator. So the pink stuff, when you type that in your calculator, you get 338,350. And then when you type in the blue stuff in your calculator, you should get 5,050. And then now type that stuff in for your final answer, and you will get 308050 for your final answer. Okay, so you're allowed, when you've got parentheses, you're allowed to break up the summation, and then if you see anything squared or cubed, I would go and use any of these formulas. Okay. All right, one last one. This one, okay? So I'm going to break this up because I have parentheses. I can give that summation symbol to all of these terms individually. And then what I'm noticing is I've got a constant of this 5 right here that could be put in front. So I will rewrite again. Okay, and then I'll color code them. So I'm going to do this first one right here, which is from 1 to 12 of k to the third. So going back to my formula sheet, I would be using this formula right here. And again, n is the number of terms. So I have 12 terms. So it's going to be n squared, so 12 squared, times n plus 1 squared, which would be 12 plus 1 squared, all over 4. Then I have minus 5 times, and then I'll do this summation in blue. So using my formula for k squared, so it should be n, which is 12, times n plus 1, 12 plus 1, times 2n plus 1, 2 times 12 plus 1, all over 6. Okay, and then this is just a constant of 6 being added up 12 times, so 6 times 12. All right, so when you type stuff in your calculator, the pink stuff is going to be 6,084. Then we've got a minus 5 times the blue stuff, which ends up being 650. And then plus 6 times 12, which is 72. So when we multiply and add all that stuff up, our final answer will be 2,906. Okay, so today was all things summation. There's always the long way to do everything. Like here, you could start by plugging in a 1 into this whole thing here, then plus, and then plug in a 2 into the whole thing, plus, then plug a 3 into the whole thing, all the way up to 12. You certainly can do it that way. This is just another strategy to try. So if you have parentheses, you're allowed to split into 2 separate or more summations. Anytime you've got squared or cubed or to the 4th or to the 5th power, you've got these formulas you can use. Pay attention to parentheses versus no parentheses. If you have a constant, just multiply it by the number of terms. If you recognize something's geometric, you've got this formula we've already learned. Same with arithmetic. And then these new properties that might make things go just a little bit quicker for you. Okay, so that's it for today. And there'll be one more thing on section 8.1 tomorrow. Okay, bye.